Hello and welcome to Ionic Nomenclature with Dr. Kim. We're going to learn how to name ionic compounds and also how to write the formulas if you're given the name for the ionic compound. So we need to know how we write a name. First of all, if we have a metal that has a fixed charge, the name is simply going to be the metal's name plus the non-metal's name, and we're going to replace the ending with IDE, IDE. That is for fixed charge metals, which we'll review in just a minute. Another way to name is the variable charge metals. We use the metal's name. Then we have a Roman numeral. Then we have the non-metal's name, and then the ending IDE. Now the Roman numeral that goes here is, what do you think? Well, it relates to the variable charge metal. And what do we need to know about the variable charge metal? Well, we need to know its charge because it varies. So the Roman numeral equals the charge on the metal. Okay, so remember, the Roman numeral is the charge on our metal. Again, we have fixed charge metals and variable charge metals. Let's review those. The metals on the periodic table are located on the left side. So the metals are over here. Let's see what metals we know the charge for. We know the metals in column 1, lithium on down. When they're in a compound, they have a charge of +1, and we know that. It is fixed. We know the alkaline earth metals in column 2 have a charge of +2. That is fixed. We know the charge. We know the metals in column 3 almost always have a charge of +3. Now let's go back from the +3 column to these two, zinc and cadmium. These two are +2 always. So they're fixed. We know them. They're +2 all the time. Let's go back one more to silver. This one is +1 all the time, always. So it is fixed. We know it. Those are the metals that we know. We know +1, +2, +3. We know these two are +2, and we know this one is +1. That's all we know. The rest of the metals, we do not know. We do not know these. We do not know lead or tin. We don't know them. They're in column 4, the column we don't know. So those are the variables. Everything else that we don't know is variable. Our first example is going to be give the name for MgCl2. First of all, what is Mg? You are correct if you said magnesium. Do we know the charge of magnesium? It's in column 2. It's a +2. So we don't need a Roman numeral. So it's just the metal plus the name of the nonmetal plus ide. What is Cl? It's chlorine, but we're going to change it to chloride. That's it. That's the name. Notice the 2 isn't in the name. Okay, there's nothing in the name that indicates the 2. It's just plain old magnesium chloride. That is the name for MgCl2. Our second example is potassium sulfate. I gave you the name. You need to write the formula. What is potassium? You are correct if you said K. What is sulfate? Is that an element? Well, remember, names all end with "ide" for elements. That's 8. So it's not an element. It's more than one element. Polyatomic. It's in our box. Let's see if we can find sulfate. There it is. SO4 with a -2 charge is sulfate. SO4. Is that the formula? That seems a little easy, just putting K and SO4 together. In fact, that is too easy. Every time you put a metal and a non-metal group together, you have to check the charges. So we need to go to scratch paper or in the margin. K is a column 1 metal. It's +1. We just saw SO4 was -2. This needs to add up to 0. Does that add up to 0? +1 minus 2? No. So to make this add up to 0, what do I need more of? I need more K's. How many more K's do I need? I need one more. That gives me +2 to go with the -2, which equals 0. I need 2 K's for every sulfate. So the formula is K2SO4. I need 2 K's to go with sulfate based on the charges. Potassium sulfate's formula is K2SO4. Notice I didn't put the charge here or here. Don't show charges in formulas because the whole thing adds up to 0. So we don't need to show the charges because it equals 0 now. So do not put the -2 or the +1 in your formula. It's just K2SO4. Moving on. This is a hard one. Fe3PO4 in parentheses with a 2. I gave you the formula. You need to give me the name. What is the name for this beast? Well, what is Fe? It's a new one. I hope you remember. It is iron. Do we know the charge of iron just by looking at the table? No, we don't. We do not know the charge of iron. It is not fixed. It is, in fact, variable. So this is going to get a Roman numeral in it. I don't know what that Roman numeral is yet, but I'm going to leave a place for it. PO4. P and O, that's more than one atom. So more than one atom is poly. This is going to be a polyatomic ion. Let's look for it. There it is. PO4 with a -3 charge. It's called phosphate. The name is phosphate. So this is iron with a number, phosphate. What does that number mean again? Let's check. The Roman numeral is the charge on the metal. Well, I don't know the charge on iron. Can I figure it out? Yes, I can. I can figure it out by working backwards. So somewhere on scratch paper, we have 3 Fe's. We have 2 PO4s. PO4 had a -3 charge. We don't know the charge on the iron. But we do know the PO4. So we can work backwards and figure it out. There are 2 PO4s. So what is that total? Well, if they're -3 each and there's 2 of them, it is -6 total. So what are the 3 irons total if it has to add up to 0? Remember, this has to add up to 0. Well, the 3 irons have to be 6 because 6 minus 6 is 0. So 6, but that's for 3 of them. What are they each? Well, if 3 of them are +6, then individually they must be +2. And it's the charge on one of them that goes in the parentheses. So this is iron 2 phosphate. That is how we get the 2. We work backwards by knowing the nonmetal's charge, looking at the total, figuring out the total on the metal, figuring out what the metal is individually. The individual charge on the metal is what goes in the parentheses. The name is iron 2 phosphate. That was a tough one. My last example is nickel 3 bromide. I have given you the name. You need to write the formula. What is nickel? It's one of the new ones. Yes, it is Ni. Now this had a Roman numeral. That's because if we look at nickel, we don't know its charge. We don't know. It's variable. What does the 3 mean? Does it mean there's 3 nickels? No. If you remember, the Roman numeral gives us the charge on the metal. So that means nickel is +3 in this example. It's combined with bromide. Bromide stands for bromine. What is bromine? Br. So is the formula just NiBr? That's too easy. Again, every time we put a metal and a non-metal together, we have to make sure the charges add up to 0. What's the charge on Br? Br is a halogen. It's -1. Ni is +3. Br is -1. How can I make this add up to 0? What do I need more of? You're right if you said I need 2 more Brs. Now I have +3 from 1 nickel, but I have -3 from 3 bromines. That equals 0. So the formula is Ni, just one of them, and then Br3. NiBr3. 3 Brs for 1 nickel. NiBr3 is the formula. Don't show the charges in the formula. Don't put the minus or the +3 here. This is our scratch paper. This is the final answer. This is the formula. And I hope this has helped you with nomenclature for ionic compounds. Good luck.